Welcome to the webinar Research Proposal Tips and Funding Opportunities for Primarily Undergraduate Institutions. I'm Jörg Schlatter, the manager of the ACS Student and Postdoctoral Scholars Office. I will be your host for today's broadcast, which is being co-produced by the Council on Undergraduate Research and the American Chemical Society. At this point, you should view actually the opening slide, but as you see, it is a little bit cut off. As I walk through the introductions, we will work in the back end to view this slide properly sized. So the speaker of today's session will be Dr. Nancy Jensen, who leads the ACS Office of Research Grants and also serves as program manager for the ACS Petroleum Research Fund. Also, we will be joined by Dr. Lindsay Curry, who's the executive officer at Council on Undergraduate Research. We would love to get you involved in the discussion. You can share your thoughts and questions in the questions panel here in GoToWebinar. The recording for today's webinar will be made available once it has been edited. And now I'm pleased to turn the time over to Lindsay. Lindsay, if you could unmute yourself. Oh, I see you did it.
Welcome, and thank you so much for joining us today. As Jörg said, my name is Lindsay Curry, and I am the Executive Officer at the Council on Undergraduate Research. I'd like to start today with a huge thank you to the team at ACS for making today possible. When we had started planning this months ago, we had hoped to all be together at the ACS headquarters, and the team there has made it possible for us to bring it to you easily and safely from our homes. So thank you to Krish and Jörg for making this possible today. I have so much appreciation for today's presenter, Dr. Nancy Jensen. She's an incredible supporter of the Council on Undergraduate Research and truly believes in the importance of undergraduate research experiences. For those of you not familiar with CUR, our mission is to support and promote high-quality mentored undergraduate research, scholarship, and creative inquiry. And we do this through our memberships, programs, and services, all in support of undergraduate research and to serve both mentors and students. We have a community of more than 13,000 individuals and 700 institutions. But I don't want to take any more of your time and virtually stand between you and this valuable content. So please, let's welcome Dr. Nancy Jensen.
Well, thank you, Lindsay and Jörg, and thank you not just for the introductions, but also for helping get this event together. We've been hoping to do this for some time, and we hope that this will indeed be useful to you. Whoops. Uh-oh, okay.
Nancy, you now have keyboard and mouse control.
Thank you, thank you. Panicking here for a moment. Okay. Well, I'm losing, this is, okay, I should be able just to page it, and it's not paging. Okay, there we go. Okay, this sorry for this interruption here. We tried this on Friday and it worked fine. So of course today, when we're doing it for real, there's an issue. At any rate, my background here, I'll point out very briefly, which is very varied. But I did start my career as a secondary school teacher and got very involved with student research projects. So I understand the importance of people at all levels, students at all levels, having those kinds of experiences to not only prepare them for future goals, but to get them enthused about science and the excitement of such a career. Okay, I still do not have control of the keyboard. Chris, can you help me here with moving slides? I have no control of the keyboard.
Yes, Nancy, if you just say when you'd like the slide advanced, I can do that for you.
Very good, very good. Okay, so we're ready to advance. Okay, as Jörg said, we're taking questions in the poll and the questions and polls area in this in the corner of your screen. However, I know if you're like me, sometimes you think of questions later. You may send me questions at n_jensen@acs.org. I'll be happy to answer them. And actually, that Jensen should be, the J should be a lowercase j. Also, we're taking soliciting ideas if there are things that we touch upon, because this is kind of an overview of a variety of things that you would like to learn more about in depth. Please let us know, and there's certainly the possibility that we could organize future webinars that would go into some of these things into greater depth. So again, contact me or send something to the chat, the question box, if you have ideas along this line or want some further follow-up. Okay, next slide. Okay, the big question, the most pragmatic question in all of science is, how will I fund the research? It doesn't matter what level you're doing it, people are involved, supplies are involved, facilities are involved, it costs money, and the money has to come from somewhere. So this is the core of what we're going to talk about today, is some things about funding. Next slide. Okay, there are two essential elements of a successful grant. One is a great idea. So you say, duh, that one was obvious. The second is effective presentation of the idea. What you may not realize is they are equally important. You can have the world's best idea, but if you do not present it effectively, your chances of funding are next to zero, because this is a competitive process. And as we'll go through and show you today, there's several factors that people consider when they're thinking about which grants to choose to fund, because there's always more people wanting money than there is money to go around. Okay, next. Okay, we've got a general outline of what we're going to talk about today. We'll have some general proposal rules, and then we will also have talk a little bit about PRF grants. That's the Petroleum Research Fund, which some of you I know think petroleum is a dirty word. But you're going to find out that probably the Petroleum Research Fund is not what you thought it was. And then some general proposal writing tips and some final thoughts. Okay, next. Okay, the general proposal rules. We're going to do kind of a countdown here. The first thing is to know the agency's mission. Every funding agency has its ideas and rules about what it funds. Sometimes it develops those themselves, sometimes it's legislated as by the government, and when they give funding to NIH and NSF or DOE or all of those things, or when private donors come up with something, or, as you're going to find out in the case of PRF, when a court case and a court make the guidelines of what can be funded, at least in the general principle. Typically, a proposal for one agency is not suited for another, in the sense of you can't rip the cover letter off and send it to the next agency. You need to focus. Now, that does not mean that your research program may not be applicable in several areas. For example, the easiest one is to say you may need instrumentation, so there are grants for instrumentation. And then you'll have a grant that deals with other types of science that you're doing. Sometimes you can break the science into pieces, and I'll give you an example and when we talk about PRF more specifically. The other thing is, don't attempt to contort the agency's mission to fit your ideas. You've got to fit the agency, not the agency fitting you. So again, we're going to talk more about this as we go along. Next slide. Okay, read the instructions carefully and follow all instructions. Again, each agency is different. Make sure that you understand the rules and the guidelines, whether they be the big overall rules or the nitpicky rules about how to set up your bibliography, and follow those instructions carefully for that agency. A common reviewer's comment is, if the PI can't follow instructions for proposal, then the PI can't possibly follow instructions to do elaborate research. Approximately a third to a half of our reviewers and decision makers are very, very picky on this point and on the point of typographical errors and attention to detail. So can't emphasize that strong enough. Okay, point number 3 on the countdown. Okay, your proposal should convey the attitude that you have an important problem. You're the person to do the work, and that you can come up with a solution to the problem, or at least a long way along the path towards a solution. But something that some people forget, particularly people that are starting the grant writing process, is you need to make it clear that you're relevant, that you are aware of previous relevant studies. A common beginner mistake is to be so excited about your idea, and you know there's some things out there in the literature that aren't really that supportive, but you just kind of blow over them and ignore them. Not a good idea. You need to address those. Now, how do you address those? Well, you address those by saying what your plan is going to overcome those problems, or how what you're proposing to do is different, what the shortcomings were in those. But you need to address those. You have to take the good and the bad. You take the state of the art where it is. You're going to do something new, and you have to consider both the pros and cons. The world is not a perfect place, as we're finding out in this moving these slides along. Okay, number 2. Okay, the great scientific idea, we mentioned that already. That's a little harder to teach than the grant writing skills. And I might point out that that's hard to teach. Grant writing skills, every one of you listening to this talk can learn good grant writing skills. So the 50% that involves effective presentation is a learnable skill, quite learnable by everyone. The novel idea is a little trickier, but still I have some ideas on that, although we won't go into them here, except for this one brief thing. Novelty derives from detailed study. Know your field well, know what the issues are, know what the problems are. But the thing that really leads to the big advances is the observation. The difference between the really good scientists and the people that do okay science is often how they cope with things that happen that are unexpected. Everything from Perkins in discovering the first man-made dye, which led to the dye industry and arguably to the pharmaceutical industry. He did that as a student, by the way. And to modern day successful people, the leaders in the chemical field, will tell you about stories where they were doing some experiment. It didn't turn out like they expected. They analyzed why that was, thought about why that was, and that led then to a whole new area of research and important things. It's also in my experience. I was very lucky to step into a graduate project when I was in getting my PhD that was an observation that was totally diametrically opposed to what was believed in mass spectrometry. It was believed in mass spectrometry that all fragmentation started from charge and radical sites, and yet this observation suggested that it was the long chain molecules in close-shelled collisional activation were actually fragmenting as far away from the charge site as they could, and indeed quite the exciting research for a graduate project. So don't ignore what the molecules are doing. I used to tell my students when I was in secondary school, the molecules do not read and write. They do what they want to do when they want to do it. And the sharp observer, or the keen observer that observes these anomalies, often that's where you get really the bright ideas, the really creative new ideas. Okay, next. Okay, this is very important. Yes, a program officer is the one that takes your proposals, is the one that sees they get reviews and all that. But any agency, a big function of the program officer is to provide information. Now, we're not going to tell you what to research, but we can help you focus your project or determine if there's aspects of your project that will indeed what you propose to do that will fit with the agency's mission, and help you what we call frame those your research to fit the mission, if there are ways to do that. And I will tell you that in about 85 to 90% of the cases of people who call me and ask, had they started out the way they initially indicated, probably would have been out of scope. But we talk about what they want to do for research, and we're often able to find ways that it will indeed fit in with the fundamental research of petroleum research. And do that. Don't wait till the last minute. If you're thinking about doing writing a proposal, get the information. Program officers can also help clarify the rules if you don't understand those guidelines. Remember, it's so important to follow them, but if that's not clear, they're also the ones that can help with that. Shouldn't have to say this, but it's very important. Always be polite, respectful, and honest when communicating with the program officer. Yelling at a program officer is not productive. And trust me, if you are caught in a deceitful communication with a program officer, that is very detrimental to your long-term reputation. So always be honest, polite, and respectful. They're there to help. They're not the ones that make the ultimate decisions. So again, interact with them in that mindset. Okay, next. Okay, we're going to talk about PRF grants, and I believe we have an audience question coming up next. And that is true or false. PRF has grants which are only available to undergraduate institutions. So true or false?
And we will leave the poll open for another 5 seconds. And 5, 4, 3, 2, 1. Nancy, it looks like it's about half and half, true and false.
Okay, so this is not a wasted effort then. Okay, do you want to go on to the next slide then? Okay, that slide is true. PRF has 4 types of grants, and you will see in my slide that they're not all printed on there in the same typeface. There are 2 types, new directions and doctoral new directions, that are for PhD providing institutions. But we have 2 types of grants that are only given to PUIs. That is primarily undergraduate institutions. They cannot have a degree higher than a master's degree in their department. So this is, they can have a master's, bachelor's degrees, associate degrees, that they're all eligible. If there is a program in the department like a general environmental science, we see this occasionally, where there is a PhD and for example, the chemistry department or the physics department, et cetera, is involved in it, then that's going to be a problem. But otherwise, if it's strictly a master's program or undergraduate, yes, there are 2 types only for undergraduates. Doctoral investigators cannot, in doctoral institutions, cannot apply for them. Okay, so what are these 2 grants? One is the Undergraduate Research Grant, or the UR grant. This is for faculty in non-PhD departments. It is a grant for 3 years. It has a value of $70K. Now you say, well, is that a lot? Not much, whatever. Well, in the PUI setting, that's a fair amount of money. It becomes more impressive when you understand that we do not allow any overhead. That money has to go to supporting students, supplies, a portion of it, but there is a cap to that amount, can go to PI salary and to travel, but those are limited in amounts. Those are usually for established professors, and we do expect the research to be different than what they've done before, not just an extension of that, but something that represents a considerable new challenge. And the other is the undergraduate new investigators. These are for faculty and PUIs within the first 3 years of their appointment. They must be within the first 3 years of their first appointment. If they change schools, it still goes from the first appointment. 2 years, $55,000, and again, no overhead. And similarly, the kinds of things we support. The undergraduate research is 3 years because we understand that most of those are in the summers. Obviously, that's going to be the same for the new investigators, except they're in the pre-tenure position, and so those are grants with the idea of helping them establish their track record to get on the tenure, to progress on the tenure track. Okay, next. Okay, in 2019, PRF awarded 37 UR and UNI grants with a total value of $2,335,000. Now, the way that works is that we have this trust fund, and the financial powers that be at ACS have a formula by which they figure how much we can take out of the trust fund on a given year. It's a magic formula. And so that the trust fund stays perpetual. We want to keep this going forever. And so our available funds by this magic formula for 2020 are $18.5 million for funding proposals, and that's all 4 types of grant proposals. But the important thing I'd like for you, to take away from this is that how much goes to UR and UNI grants depends on how many proposals we get, because that fund is prorated across the 4 kinds of proposals in proportion to the number of proposals submitted in each area. So if there are, and this is really total fantasy, but if there are 50% of the proposals, total number of proposals, are UNI and UR grants, then 50% of the grants will be in those areas. So again, it relates to how much participation we have, and I think that's very important for you to keep in mind. The more participation, the more funds go to this area. Okay, next. Okay, we like to brag on impact of PRF grants. They're known for being starter grants. It's a deliberate decision. There was a number of years ago, there was a panel of 50 scientists plus some lawyers involved, and we'll get to the reason why lawyers are involved in this later. You know, how could we make the best use of the money? How could we make the most impact? And so this is why the selection was made to do the starter grants, either starter grants for beginning professors, for their first peer-reviewed funding, and then also the seed money grants that allow research in novel directions and for researchers to reinvigorate their program with some significantly new directions. And just as a simple brag, 30 Nobel laureates have received PRF funding in their career, and by my count, about 22 or 23 of those received the funding for research that was affiliated with what they won their prize. I also point out that we do have one person who has served on the board of PRF, who's also gotten grants, of course, who we're very excited about, who was a Nobel laureate this past year. So we actually even have a board member that was a Nobel laureate. Okay, next. Okay, so how the history of all of this, and why is it Petroleum Research Fund? Well, in 1944, there was a problem. There were 7 petroleum companies that had bound together in an illegal way by the law of the time, and were violating antitrust laws, misusing the patents for catalytic cracking. As petroleum comes out of the ground, the amount of it that's in the gasoline fraction is not proportional to what we need for demand, even in these times. And so there's these were the processes for breaking up larger molecules to make it suitable for gasoline. And again, they were in trouble. They had violated the laws. And so as a result of that, the punishment was that they turned over the patents and the proceeds from the patents to a good cause. And the court set it up this way. The trust set up a trust and a grant program to be administered by the American Chemical Society under the jurisdiction of the federal court. Now, that's interesting because the documents which founded this and a subsequent document that was affiliated with a technical detail related to it govern it to this day. So in terms of, you know, why don't you go and do something else? Why don't you change what you're doing? Why don't you be more modern? Why don't you call it something else? We can't. The court set it up this way. That document is still in effect. And to do something different, the court might say that ACS no longer was the proper steward of this fund. So some of the things that you think may be outdated and improper, go back to that. This also tells you why there's this big rule in there about no patenting or no using of research, the results of the research for profits. Again, that goes back to the origin of the fund and the fact that it is still has to abide by the court's ruling. Okay, so we mentioned the seed money already, so we can move to the next slide. Okay, we got a true and false question here. The subject matter of PRF grant must be research directly applicable to commercial value in the petroleum industry.
We will close the poll in about 5 seconds. 5, 4, 3, 2, 1.
And the results, Chris?
Sorry about that. It's about 83% of respondents indicating false and 17% indicating true.
Okay, so that's good. It could not be more. It could not be more false. And we're going to see in a minute some actual language from that, but this could not be more false. It is not about commercial value to the petroleum industry. It is not about the petroleum industry. What we are talking about here, and we'll go to the next slide because I think that has the language. Okay, this is from the trust agreement. The trust agreement. The recipient shall use all funds exclusively for the advanced scientific education and fundamental research in the petroleum field, that's in quotes, which may include any field of pure science in which the judgment of ACS may afford a basis for the subsequent research directly connected with the petroleum field. Okay, so notice it says pure science. That's the first thing, fundamental research in pure science, but it has to have a link with petroleum. So what do we mean by petroleum? Actually, at another point in the document, it defines petroleum, and I'll bet you it defines it in a way that you didn't expect, because it doesn't just define petroleum as crude oil. It's crude oil, shale, coal, natural gas, any of the natural hydrocarbon fuels. Now, and you put that with pure science. So what are we talking about here? Well, if you're an organic chemist, you're talking about an extensive toolbox of compounds you can work with. You're talking about working with these basic materials. And we know that even if we go to alternative energies, we're still going to be using for a good long time that supply of raw materials for making a whole variety of other materials currently that we use and probably ones in the future. So it has to do with the science of the materials there. Similarly with geology, it has to do with the science of the formations in which we find these materials. So again, now back to what I said about your friendly neighborhood program officer being a very important person. This is why if you're thinking about doing a project, it's very good to talk to your program officer, because it's very often that we can find that there's a way that we can take the focus on the fundamental part of what you're doing to this very basic research affiliated with very basic materials that we're all familiar with. Okay, next. Okay, the seed money grants must be significantly different than previous work. This includes both the starter grants, so it should not be, if you're a beginning professor, it should be different than what you've done in a postdoc or in your PhD work. And preliminary, because it is seed money, preliminary results are not necessary. In fact, extensive preliminary results tend to be counterproductive, because what we're trying to do is give you money to start something. And we understand it's higher risk than maybe other agencies are interested in. You need to have a well thought out plan, but as far as preliminary results, no, that is not necessary. In fact, if you have so many preliminary results that you have a publication, that's problematic. Next. Okay, so it must have this petroleum relevance. We must be able to relate it to the petroleum field, and that relationship should not be a stretch of one's reasoning. It must be in one of the specified disciplines, and we're going to listen to this in we're going to list this in the next slide. And the PUI has to articulate a description about how the proposal is fundamental research in the petroleum field. Again, this is a way in which our program officers can help you with this. Sort through to see if there is a way to focus it to be within what we can fund. Next. Okay, these are the 10 areas. Now, it has to have petroleum relevance and be in one of these areas. So we have, and these are listed with numbers because we have our decision committee, the committee of the ACS that oversees this and makes the final decision on the grants, is divided into 10 committees. So that's the numbering system here. Not that synthetic chemistry is the best, although actually that's my group, so you know. Never mind. Okay, so synthetic organic, geology, inorganic, physical organic, surface science, chemical physics, polymer science, geology, geophysics, chemical and petroleum engineering, and material science. Okay, now I'm going to take a couple of examples from this right quick about the fact of how we can focus. I get people that, you know, have a long-term goal of making some natural product that might have medicinal effects. That's getting kind of tangential from petroleum here. He's going to make a medicine. In fact, that is in an area that we really don't want to go to because we need to show that fundamental science. However, if they're synthesizing a molecule, it's probably going to have some sort of stereochemistry, substitution, ring type formation, whatever. That's never been done before. That's fundamental science. For a 2-year or a 3-year grant in a PUI, to focus on that fundamental science, that fundamental chemical reactions, is perfectly fine. Then once you have that research under your belt, go ahead and apply for another grant and move the project forward. We said nothing commercial here, and you see petroleum, chemical and petroleum engineering. How do you get something in petroleum engineering that's not commercial? Well, a prime example of that is we see a lot of proposals involved in modeling of flow through various different kinds of materials and structures. So again, I encourage you strongly, if you have an idea, to contact one of our program officers, and we can help you find out if we can focus on a fundamental portion of that that would fit within the program. Next. Okay, and these are some exemplary areas of things that are excluded, things that get way too tangential from the real purpose. The other thing, which I think should be self-evident, is since it's the Petroleum Research Fund, we cannot support alternate energy proposals. So if it has to do with alternate energy, that's a problem. Or simply saving petroleum, if that's the motivation, that's not going to cut it. But if we're talking about alternate energies, then that will be that's outside the scope. So that's the kind of thing. And again, your program officers are there to help you. Can't say that often enough. Next. Okay, in our proposal processing, you put in a proposal, and this is PRF proposal. Again, I guess I should have said this. I think now you should understand why we can't take the word petroleum out of this name of this grant system, because again, it goes back to the court and the history and all of that, and the court still being being the ultimate authority we have to report to. Okay, so proposal processing. You put it in, it takes a long time. Why does it take a long time? Well, right now we take them in on a grant a grant system that is extra server, and that has to be then transferred into our system. This is what we call the transfer the IGAM into the PRF database. We are getting a new data system. There will be in the fall. We expect to have a little. If you've applied before, you will see there's going to be some differences in the forms and how we're doing it. We're getting a new data system based on Salesforce, and this will be steps 1 and 2 will be merged a bit in that case. But nonetheless, step 3, they're evaluated. The proposals are then, as they come in, are evaluated by the program manager. Now, we're not looking for the scientific quality. What we're looking for is, do you have everything there that you need? Does the budget comply with our requirements? Are the signatures there that we need? All of this, and importantly, is it within the scope of what we can fund? Now, if it doesn't meet those criteria, then it is withdrawn without review. And again, a way to avoid this is to talk to a program officer before you write the proposal. Step 4, okay, once we have that, then the proposal is sent out to reviewers. We typically only ask a reviewer to do 1 proposal per grant cycle. So reason for this is, and this is particularly important for the new investigators, if you give people a stack of proposals, they're going to compare. And what we want to try to get for our applicants is we can't give money to everybody, but we can give them help. We can give everybody that applies or everybody that calls us, we can give assistance to, we can give information to. And so we want to get them the best reviews that we can. We try to get them 3 reviews from 3 different people so that they have that information to help refine their either their grant writing skills or refine their ideas to make it more fundable if it's not funded. Okay, so then we collect these and they go to the science panels. Remember the list I showed you with the 10 listings? Each one of those areas has 3 scientists who are on the PRF committee that make that review all of the proposals in that area and make the recommendations for funding based on, again, what we have prorated out. They're not just prorated out between the doctoral schools and the undergraduate schools, but within each of the groups, we prorate the funds out, again, depending upon the number of proposals in each area. So if committee 1, my synthetic organic, has twice as many as the engineering, it will get twice as many proposal slots. A bit of a complicated process. Entertains me for a couple of days when I try to sort all that out, but that's the way it's done. Okay, so we send these out to the reviewers. I will also point out that in our committees, in each of these committees, we have 3 people on each of these, we try to keep, particularly for areas where we have a fair number of undergraduate proposals, like committees 1, 3, 4, and 6 tend to have larger numbers. We try to keep at least one person on that committee that is from a PUI. Again, to keep the perspective there. So most of our people are from institutions. Obviously, we have a lot of people from doctoral institutions. We do have a few from industry and national labs occasionally. So again, mainly academic. We do try to include PUI, particularly in the areas where those are more common. Okay, so then we forward that to scientific panel. We have a decision meeting. This time it's going to be virtual, which is going to be interesting because we've never done that before. And then technically that's not the end of the story, because this is a committee of the ACS Board of Directors. The recommendations of the science panels have to go to the Board of Directors and for the final approval. Now, that means we send out some letters saying you have been recommended, and we often get some nervous responses. Never in the history of the universe has the Board of Directors failed to approve what the scientific panels recommended, but they do have that right, so we have to use that language. And then finally, we notify the PIs, and you will get then excerpts of your reviews. We say excerpts because we do remove a few things from them. We remove, for example, if there's something that reveals the identity of the reviewer, that's removed. So if it says, you didn't quote my paper, we say, you know, paper so-and-so, John Smith, Jacks, it was not cited. We also, because we get reviewers from a wide variety of things, some people are not as familiar with the PRF rules as others, and I just recently had one that came in with this PI, this is a great idea, the PI should patent it. Well, again, we don't allow patenting. So we remove anything that would be contrary to PRF rules, anything that would reveal the reviewer. We also edit if there's anything that is personally inappropriate, like this is the stupidest reviewer, or this is the stupidest PI I've ever seen. You know, things like that are not productive. So, but we try to get you everything that's scientifically meritorious. Okay, next. Okay, so in the reviewer's evaluation, they're looking just at yours. They're going to look at the agency's criteria, the novelty, approach, grantsmanship. Grantsmanship is very important. Clear presentation, readability, free of typos, all those kinds of things. Next slide. And they're going to look at things like, is it doable? Is the PI realistically address potential challenges? Do they recognize potential challenges? That's probably first. Do they recognize potential challenges, and do they address them? So it's good to, you know, good to acknowledge if you think there might be a problem, say, you know, this may be difficult, think it's going to work because, or if it doesn't work, we can do this. This is the kind of thing you want to add. Okay, so that's the reviewer process. Now, that's step one. That's no comparison. That's just based on your project. Let's go to the next page. Okay, so then it goes to the committee. These individual reviews and your proposal go to the committee. The committee uses the reviews just like you do for information purposes. They're not bound by what the reviewer says. They can add their own opinions and they can disagree with the reviewer. But the reviewer's comments are there to help you and to help the committee. Now, when it gets to the decision committee, this is the first time in the process where it's competitive. And in that sense, they're going to be having to make a choice because they're going to have more proposals than they have money. So what becomes extremely important there is the significance, approach, and innovation. Those are the big 3 topics. But investigator capability and research environment and research environment capability are bigger issues, admittedly, in the PUIs than they are in the doctoral schools. Next. Okay, we can't give out examples of proposals because it's hard to write a generic proposal that would be reasonably comprehensive and informative. But one way you can find out is be a reviewer. And if you want to be a reviewer, you can send me your name and I will direct your review. If you're in an area that's appropriate to one of our areas, I can direct your information to one of our program managers, program officers, and they can, we can work you in here. As mentioned in what was running through at the beginning of this, there is free training on ACS Reviewer Lab. This is not a trivial thing. It took me the better part of a couple mornings to go through it. It's like 6 or 7 modules. It is done by pubs and focuses on publications, but virtually everything that's in there is applicable to doing a review of a proposal. Ethics issues, how to approach analyzing the document, how to write up your report. The main difference is that if it's for publication, the experiment has already been done, the data analyzed, and it takes a little more detail there to go through in detail about what has been done and is this done correctly and appropriately. Whereas with the proposal, it's a little more nebulous when you're assessing whether this is something that's viable and what the researcher is, what the PI is proposing. Next. Okay, we're going to do, we don't have a lot of time, but I want to go through several of these, some general proposal writing tips. I have many more than are going to show up here, but we're going to try to go through in the next about 7 minutes several of these. And again, please feel free to follow up in your questions, or if we would like to delve into these a little bit more, we certainly can do that at another time. Okay, next. Okay, number 1, creating a positive impact, good first impression. I cannot emphasize strongly enough how important your first paragraph is. That's the key. Do not start out with a paragraph of saying 50 billion barrels of oil are used in the country this year. Carbon dioxide is given off. It hurts plants and animals. You lose your audience, no matter if it's a Nobel laureate or a first-time reviewer. You need to start, and I'll have an example here in a couple of minutes. You need to start focusing the reviewer on and the decision maker on where you want to go with this. What's the problem you're studying? Why are you studying it? What's the importance here? You want to make that first paragraph is very critical to focus the reader on the importance, where it's going, why it's being done. And the second thing that gets a big star is the careful presentation. We've touched on this before, but it's absolutely critical. And I have seen as much as a third to a half of reviewers pretty much discount a proposal because they found typographical errors and figures mislabeled and all of that. There are many people that are hypercritical about that, even if the underlying idea is very good. Okay, next. Another thing you need to show is demonstrate managerial skills. It's not just the idea, but can you carry it out? So you have to have a clear and pragmatic plan. Show wise use of resources. Do you have are these going to be the resources to accomplishment? Is the time frame reasonable? Do you have the facilities? And be well organized. One other comment on the facilities, I might say, it does not necessary that you have all the facilities underneath your roof. But you have to have a reasonable way to, if you need other facilities, other equipment and so forth, a reasonable way to access them. If it's something you need every day and you have to go 500 miles, that's not practical. If it's something you need a couple times during a semester and you can get that done 50 miles away, that's probably good, or you can ship it someplace. But this is particularly important in the undergraduate schools, is you have to be able to have access, not necessarily under your roof, but access to a reasonable, the equipment and supplies in a reasonable sort of way. Next. Okay, the basic concepts, these are fairly straightforward. Right to be readable, appropriate level of detail, and I'll give you a clue on that one in a minute. Finding out how much money is available and following budget guidelines. Remember, this managerial skill it's budget is not just is not just something to be there and wish at. That's something you need to pay attention to, because that shows your managerial skills in one way. And then have clearly defined hypothesis, goals, and approaches. Don't have the "we're going to give me money, I'll go in the lab and we'll figure out something" approach. Hypothesis, goals, approaches. Next. Okay, you need to make it. Okay, state your research trajectory. Okay, skip this one. Let's go to the next one. I think we already covered that. Okay, clear and impactful writing. This is too wordy to put it in one of the questions, so you're on your honor to think about this. Which of the following do you think is the best way to convey the overarching nature of your research? Okay, so number one is the proposed research is directed to the synthesis of analogs of dimethyl chicken wire, a natural product known to have antimicrobial properties. 2, the proposed research includes building a library of compounds and testing them for antibody activity and cancer prevention properties. And finally, 3, the proposed research is directed to the synthesis of fluorinated analogs of dimethyl chicken wire, a natural product known to have antimicrobial activities. The analogs are projected to have better bioavailability and accordingly higher potency than the natural product. Okay, so we have 3 of them here. Since we're kind of limited on time, in your mind, pick which one you think is the best way to, this is going to be that first paragraph. You know, how are you going to start it? Where's it going to start? Okay, I will tell you the one that I like least is number 2. You're everything there. Build a library, test them for a bunch of different things, all over the place. You're not focused. You're going to lose the audience in this one. Number 1, not bad. But number 3 is my favorite, and this is why, going back to what I was saying about that first paragraph, in this, we focused very tightly on what we're going to do, why we're going to do it, and the motivation behind the whole thing. Again, very important to focus the reader, that's going to be the reviewer or the decision maker, on what to expect, why this is there. Next. Okay, a second one. This one is, what do you think is the best way to convey the newness to reviewers? And we have the proposed research that's never been done before and will revolutionize organic synthesis. The proposed research provides a new method for functionalization of heterocyclic compounds in a one-pot synthesis using an iron catalyst. The proposed research provides a novel approach to functionalization of heterocyclic rings. Okay, again, you're on your honor to make a decision. Number 1 is the one that I hope none of you voted for, because that's the used car salesman approach. It's a big turnoff to reviewers and decision makers. It smacks of the hyper salesman. Number 3 is not bad, but it has one word in there that's problematic, and that is novel, which is a word that really doesn't mean much. Number 2 obviously then becomes the preferred one here. Even new is a little bit edgy, but certainly novel is an overused word that really is pretty lacking in substantive meaning. But again, back to being specific, not overly detailed, but being specific with what you're doing. Okay, next. Hypotheses. Hypotheses are a simple statement. The proposed research will test the hypothesis that a new catalyst will XYZ catalyst will oxidize compounds having AB functionality, or we hypothesize that. If you can't reduce what you plan to do down to a simple hypothesis of a statement or two, then you don't have it clearly organized in your mind. Yes, there will be much more to it than this, but you should be able to boil it down to a simple statement. Next. Okay, I've highlighted, there's proposal guidelines, they're all over the place. These are exemplary ones, and there may be many more, there may be many less, depending on your agency, but I highlight page limit and word length. In PRF, we have a 4,000 word limit for the narrative of the proposal. And I can tell you that there has been no proposal in the last, probably now it's about 12 years, in which there were 2,500 words or less that has been funded. We have no minimum page number. Why is that? The why is, remember I said the appropriate level of detail. If you write a PRF proposal and it has 1,500 words, and we have a 4,000 word limit, that probably means that you have not provided enough detail, either in your background, in your proposed experimental procedure, etc. So the page limit and the word limit, not only the word limit and page limit, obviously you can't go over that, but they're also a hint to, are you being detailed enough? Next. Okay, I found that the bibliography can be very revealing. First of all, did you use the required form? Again, people are picky about this. Age of references. If I see a bibliography with a bunch of old references, I am very suspicious, because very often this means one of two things. Either you haven't done a thorough literature research, you've resurrected something you did 5 years ago and coming back to it and aren't up to date with what's happening in the field, or it may represent something that's of no longer of interest to people. Now, it isn't always a negative thing. Sometimes there are reasons why research becomes relevant that couldn't be done. I give the example of the time-of-flight mass spectrometer. It was the first mass spectrometer discovered. It was discovered in about 1900 and wasn't useful in any real way until the 1990s. The reason being, the ions move so fast through the tube that the flight tube collecting the ions, detectors and computers had to be developed that could do that high-speed data collection. So things do happen like that, but be wary if you have a lot of old references. Also, if you resubmit an application, do not forget to update your references. Nothing's more embarrassing than the newest reference is 2 years old and there's been something come out in the last year. Okay, and then the number of different research groups cited. If you cite one group very heavily, you are probably doing Me Too science, and there's a good chance that that group is going to either has tried what you're proposing and it hasn't worked, or they've beat you to it. So if you're really relying on that, you have to worry about that being Me Too science that may not be very productive. Next. Okay, I can't resist this slide, and I can't resist the importance. Typographical errors are a huge problem. Avoid them at all cost. And if you're like me and proofing is difficult, sometimes even having a friend or a family member who is not really a scientist proof it may even be better, because they may be more sensitive to the typographical errors than somebody that's reading it for the science. And next. Okay, there's some common errors here. I think we've pretty well covered these. The beyond the capabilities of investigators, students, or institutions is particularly important in the PUI scenario. We've touched on that earlier. Again, that does not mean that you have to have everything in your institution, but it has to be practically obtainable. Next. Okay, missing pages, unfocused. Again, I think we're kind of reiterating what we've talked about earlier. And now, next, the final thoughts here. Next. Okay, rejection is inevitable. I recommend if this article that was in Nature, February 20th of 2020, volume 578, pages 477 to 479, rejections are inevitable, and I think they make 3 very strong points. Don't be overcome by emotions. Get feedback, use the feedback you're given if you're sent the reviews, and mind the details. That theme keeps coming up, mind the details. Typographical, following instructions, etc. Next. Okay, we are celebrating 65 years of awarding PRF grants at the national meeting in San Francisco. Obviously, things are a little bit crazy at this point, but we do have a presidential symposium, and it will include Harry Gray and Robert Grubbs, the Nobel laureate, one of our Nobel laureates, as well as Richmond Sarpong, John Brennicke, and representing the geology sections will be the chair of our PRF committee, Kate Giles. And we're also collecting recipient stories. So if you happen to be a person that has received a PRF grant, again, you can send them to, if you didn't get a notice about that earlier, you can send them to me, or you can send them to PRF Info. And I think we're down to my people. Can we get the next slide? Okay, this is our group of people. You can also find this on our website, which is www.acsprf.org. You can get to this, and this will list you the people, and these are the areas in which they are the program officers. Okay, Jorg, do we have some questions?
Nancy, first, let me thank you for a fantastic webinar. It was very, very informative. And I think one message which I would like to reiterate as a former NSF program officer, reach out to your program director to ask questions before you submit your grant proposal to avoid that it's rejected or unclear. Nancy, we got many questions. We have only a couple of minutes. Let me touch on eligibility. As a K-12 teacher, I'm wondering if it would be possible for me to apply for a PRF grant. If not, can I partner with an undergraduate institution?
Okay, unfortunately, in our eligibility, it must be a tenure track professor or the equivalent. And we say the equivalent because there are some schools that do not have tenure. And our website, and we can work with the program officer what's required to establish that. But essentially, it's a tenure track professor, or tenure track, unfortunately.
One other eligibility question: is educational research that impacts career development of junior researchers that envision to work in the petroleum field fundable? Educational research.
Not educational. It has to be directly related to petroleum in terms of the petroleum materials, the physical petroleum materials.
Excellent. Thank you.
I'm being a real negative person. Here, give me a question I can
Okay, here's one about the review and the outcome of the review process. How many proposals do you typically receive, and what is the success rate?
Our success rate runs at about 20%. Of the proposals that go out for review. And in recent times, we're really trying very hard to encourage greater participation among the undergraduate schools. That's really something that is on my radar. It's on the radar of our recent PRF external review. It's on the radar of our PRF committee. And we've actually been funding those at a little higher rate. We've been funding those at more like a 25 to 30% rate recently. We really would like to see enhancement in this area.
Okay, here's a question about: is there any impact of publications of the applicant on granting the proposal?
If the work is published, if they're published publications related to that work or closely related to that work, that takes it out of the seed money category. So it would be considered a logical extension of previous work, and that would disqualify it for seed money.
For proposals that were submitted during the fall cycle, by when are PIs notified of the decision?
Okay, the decision, if it was submitted in the fall, the decision will be the week of the 20-something of May is when they will be notified.
I think
that will be notified that, whether they have been recommended or rejected. If they are recommended, it will be June after the ACS Board of Directors meets that they get the final notification.
A question about international researcher background. So if I have a green card or I'm not an American citizen, am I eligible to apply?
As long as you are in an eligible university as a tenured or tenure track professor, we do not check that. Okay. And I will point out that the URs are also available internationally. The undergraduate, the new investigators are not, because there's so many different systems of how new professors are brought in over the world. But the URs are actually internationally available in eligible countries.
Excellent. Thank you so much, Nancy. I want to point out that we recorded the whole webinar, and this webinar recording will be made available after editing. And if you have any other questions, please do not miss to reach out to Nancy Jensen and her team. All program officers are happy to answer questions before you submit your grant proposal. And with that, we are directly on 3 p.m. Eastern Time, and we thank you all on behalf of KUR and ACS for joining today's webinar. Good luck with your proposal preparation, and keep the fingers crossed that your next project will get funding. Thank you so much. Have a good and safe afternoon and evening. Bye-bye.
Thank you.